Welcome to another edition of Coonrod's Corner. Today's topic, improving insertion loss with RO4000 LoPro Laminates. Now here's your host, John Coonrod.
Hello, welcome to Coonrod's Corner. My name is John Coonrod. I am a Technical Marketing Manager for Rogers Corporation. Today I'm going to talk about the RO4000 LoPro product family and give a quick overview of some of the attributes. Now to begin with, LoPro Technology has been around for several years now, and it's been widely adopted in several different applications. The LoPro technology is associated with the RO4000 materials, and there's many different grades of RO4000 materials that can use the LoPro technology. Today I'm mostly going to be talking about the RO4003C, the RO4350B, and the RO4835 laminates with the LoPro technology, and basically showing some differences between the standard product and also the product with LoPro technology. Now, the LoPro technology is basically a low-profile copper, which means it's really a reverse treat copper. It's very smooth, and having smoother copper gives some benefits to the materials. The RO4000 materials are very well known to be used in high multi-layer applications, also has very good thermal conductivity and very low loss, and all that remains the same even with the LoPro technology involved with the product. Here I've shown a section of our data sheet, and there's a few items here that I'd like to go through quickly, and one is the dielectric constant, and specifically the dielectric constant control. You can see the tolerance for the dielectric constant is plus or minus 0.05. That's considered very tightly controlled, and in many applications that can be very critical. Also, you can see the dissipation factor is 0.003, or roughly 0.0027 for the RO4003C and 0.0037 for the RO4350B laminate. And that's also considered very low dissipation factor, which relates to dielectric losses. Now, another thing of interest is the CTE, coefficient of thermal expansion. Now, ideally, 17 parts per million per degree C would be the best number to have, because that's the CTE of copper. And you want the materials as closely matched to copper as possible for a good, robust multi-layer circuit. Now, you can see in the case of the RO4350B that the CTE values are very closely matched to copper, and the Z-axis is a little bit higher, about 32, and that's still considered very good. As a general rule of thumb, the CTE value of 60 parts per million per degree C or less is considered good for having a laminate that is robust in multi-layer fabrication. Then the thermal conductivity, you can see with both these materials, is also very good, 0.69, 0.75, and then the moisture absorption, again, very low. So this is the standard product, and when you apply the LoPro technology to it with smooth copper, none of these properties really change. They all remain the same. Over many years, Rogers has done a lot of studies on copper, copper treatment, copper roughness. We've come to understand this topic very well, and if you want more details, there are several papers on our Technology Support Hub that can give you a lot more detail. But now I'd kind of like to look at an insertion loss curve that compares the standard product to the LoPro product when using 10 mil RO4835. The insertion loss curve that I have shown here is generated by making 50 ohm microstrip transmission lines using differential length method, and you can see that I have losses that are pretty well behaved all the way out to almost 100 gigahertz. And for this particular material, the 10 mil 4835, it is used actually in some situations at 60 gigahertz for some of the new backhaul applications. And at 60 gigahertz, the standard product, which is again 10 mil RO4835 laminate, there's about 2 dB per inch loss at 60 gigahertz, and that's considered very low loss. That's a very well behaved material at that frequency. However, if the designer needs even more improved loss on top of that, you can actually buy about 0.5 dB per inch difference by using the 10.7 mil for RO4835 LoPro. So that smoother copper makes a big difference. And you can also see it's frequency related. At very low frequencies, down around 1 or 2 gigahertz, there's not a lot of difference. But once you get out into the millimeter wave range of frequencies, you can see there's a remarkable difference between the product with the standard copper and the product with the LoPro technology. The RO4000 materials are used in high-power amplifier applications and many applications where thermal management is critical, and that's because the thermal conductivity is so good with this material and the dissipation factor is low. And included with that is going to be the improvements of the LoPro technology that actually reduces conductor losses. And basically what happens is when RF power is applied to a circuit, the RF power is going to heat the circuit because of the amount of losses in the circuit. If there are less losses, the circuit's going to generate less heat. In this case, the RO4000 materials with the LoPro technology is going to generate less heat because of less losses, and whatever heat is generated is going to be very well managed because the material has very good thermal conductivity. The three different pictures I have shown here are taken with a thermal imaging camera, and what these are is really a top view of a circuit that is being heated. And the circuit itself is a very simple microstrip transmission line. We're looking straight down on the circuit. The circuit has been heated by RF power that's been applied at 3.3 gigahertz and 85 watts. Now the picture in the upper left-hand corner, you can see the insertion loss is about 1.5 dB. In this case it is dB, not dB per inch, and 1.5 dB, and this is about a 6-inch long circuit. And you can see the temperature rise above ambient is 34 degrees C. And that's a little bit of a rise above ambient, but generally speaking, that's not a very difficult thing to deal with for thermal management. Now in the bottom corner, there is another material, same thickness, and actually in a lot of regards, similar performance to the TIMO RO4350B. That's a competitor material that's been introduced on the market recently. It's a thermal set material. It's based on a PPE system. And in this particular case, they had very smooth copper, so they had low conductor losses. However, the dissipation factor was higher than what they report, and that combined with poor thermal conductivity, you can see the heat rise is about 47 degrees C rise, and that's getting in the range where it can be a concern. Now the picture on the upper right is using the same substrate essentially as the picture to the left, where it's 10 mil RO4350B, but now we're using the LoPro technology with the smooth copper, and you can see the insertion losses go from 1.5 dB to 1 dB, and along with that you get less heat generated, of course, and now the 10.7 mil RO4350B LoPro has a temperature rise of 19 degrees C above ambient, which is considered very good actually. This concludes this session of Coonrod's Corner. Thank you for watching.
For additional information and technical tools, if you're not already a member, join the Rogers Technical Support Hub and gain access to calculators, technical papers, and more Rogers Corporation informational videos. Rogers Technical Information is also available at your fingertips with the Rog mobile app, available for the iPhone, iPad, and Android devices. Check it out today.